Alright, today we're going to solve more problem on exponential equations. So let's say we have this problem. How do we begin to solve? First of all, we're going to try to understand the question. And for the fact that is and there, you can see there are two equations occurring concurrently. That means this is a simultaneous equation. But first of all, we need to apply the many laws of indices as much as possible in this problem. To first of all bring this problem to the point where we begin to solve it simultaneously. So first of all, you see this is already a simultaneous equation there. However, we need to solve this to bring it to become in this form also, so we can begin to solve. So now let's start solving. Alright, the first thing we're going to do is we're going to try to put 32, 2 and 4 in the same base, because if we must use the laws of indices, then it is prerequisite that the bases are going to be the same. So we can put all of them in base 2, because 32 can be put in base 2 and then 4 can be put in base 2. 4 in base 2 is 2 times 2, and that's 2 raised to the power 2. So we're going to replace 4 with 2 raised to the power 2. However, there is a power there which is x plus y, and this is multiplication there. 2 is already in its base, so we just leave that. 35 in base 2 is 2 raised to the power 5. 2 times 2 times 2, 5 times is gonna give you 32. Now, using the power law, where there are two powers there, you're going to simply multiply the powers. So that's going to be 2 times x is gonna give you 2x. 2 times y is positive 2y. Multiplication. I write that 2 raised to the power 5. Now, using the multiplication law, sorry. Whenever the bases are the same, you just add the powers. So we are going to be adding the powers now. We take one base and we add the power. So 2 raised to the power the whole of this times 2 raised to the power the whole of that is going to be equal to 2 raised to the power 2x plus 2y, then plus x plus 2y. Right? If you're not familiar with these concepts, I've done a video on that already, indices, so you can just feel free to watch it and then get back to the video. That's 2 raised to the power 5. So now, if you know what the equality sign means in mathematics, it shows the equality of two sides of an equation. So what it's saying in essence is 2 is equal to 2, and of course 2 is equal to 2. That means definitely the powers are also going to be equal. So 2x plus 2y plus x plus 2y is definitely going to give us this index there, which is 5. So we're going to cancel out the 2 and then we're going to work with the index, because that's the ones with the unknown variable. So the known values we're going to cancel. So 2 is going to do away with it. We're just going to do away with the 2 there, and we're going to work with the powers. So let me write this out here. So that means 2x plus 2y plus x plus 2y there should give us 5. Now let's collect like terms. 2x is like with x, and then 2y and 2y there, and that is equal to 5. 2x plus x is 3x, and then 2y plus y is going to give us 4y, and that's equal to 5. So we can call this equation 1, because we can't collect any other like term there. That's all we can do for now. So let's call this equation 1, and then look at the equation 2, and that means that's equation 2 already. So that is 2x minus 3y equal to -8, and this is equation 2. Now we're going to try solving this using the elimination method. So let's try to eliminate x. We can eliminate y, we can eliminate x. Anyone you decide to eliminate first, that's totally up to you. That's totally up to you. So let's try and eliminate x first. I've already done a teaching on elimination method, solving simultaneous equation using the elimination method already. So also feel free to check the video. I said that Whenever the coefficients are not the same, the coefficient is the number before the algebraic term x. In this case, we are considering x. So in equation 1 is 3, in equation 2 is 2. So if they are not the same, we simply kind of multiply equation 1 by 2, which is the coefficient in equation 2, and then multiply this by 3. Please let me just make a little demarcation there. Multiply that by 3. So let's do that quickly. 2 times 3 is going to give us 6x. 2 times 4 is 8, and then 2 times 5 is 10. The second equation is 3 times 2 is 6s. You see now the coefficients are the same. 3 times that will give you 9y, and then that should give us 24, negative 24. So this is our first equation, and then this is our second equation. So we're going to solve that, and let me make a space for that. Let's solve it in a new page. So let me write out the equations again. We have 6x plus 8y, and that's equal to 10, and then 6s minus 9y, and that's equal to negative 24. Now, how do we eliminate x? Is it by adding or is it by subtracting? The sign, they are the same, so whenever the signs are the same, you just have to subtract. So let's subtract there. By subtracting, we are going to finally eliminate 6s, because 6s minus 6s will give you 0, and then we can solve the equation. This is 8. This is positive 8. Alright? Minus. Now you see this negative sign there. There's a negative sign there. So this is 8 minus, and then minus 9. So we can put that in the bracket, minus 9. You see now that minus is going to give you plus. So 8 plus 9 is equal to, is going to give us 17. So you see how we have positive 17y there. The same thing with 10 minus 24. That's eventually going to be 10 plus 24, which is equal to 34. So now, collecting like terms, or making y the subject, y now will be equal to 34 divided by 17. And 34 divided by 17 is equal to 2. So y is equal to 2. So we can now easily substitute the value of y equal to 2 in any of the equation. So let's substitute it into the equation 1. So from equation 1, we have 6s plus 8y equal to 10. So now we have 6x plus 8. Now 8 times y, now y is 2, so I'm going to replace y with the 2 we just got as our answer there. So this is 6x plus 8 times 2 will give you 16 equal to 10. Collecting like terms, 6s is equal to 10. The positive 16 crossing becomes negative, and then 6s is equal to negative 6. X now will be equal to negative 6 divided by 6. So finally, if you do negative 6 divided by 6, you're going to get x equal to negative 1. So that's the answer to that problem. So I think it's very clear and easy. Thank you for joining.